This is Chapter 18. Chapter 18, we're going to talk about kinetics, which is the study of reaction rates. This whole chapter is about rates. Spontaneous reactions are reactions that will happen, but we can't always tell how fast they're going to happen. Diamonds will spontaneously turn to graphite, eventually. And reaction mechanisms are the steps by which a reaction takes place. Here's an example of a reaction rate. A reaction rate is the rate is equal to the concentration of A at time 2 minus the concentration of A at time 1. And this is going to be then all over T1 minus, or T2 minus T1. We can change these products, or final minus initial, to a delta. That's all that means. Is a delta simply means a change. So the final minus the initial. We can also put on the bottom a delta T, which just means a change. So it's the change in concentration per unit of time is what this rate is referring to. A, in brackets, is referring to the molarity of a chemical A. So anytime you see brackets, it's referring to the molarity or the concentration of that compound. Let's go ahead and do an example. This example reads, dinitrogen pentoxide reacts with water to form nitric acid. At the start of the reaction, no acid is present, or the concentration of H is 0. After 30 seconds, the H plus equals 0.1, or the molarity of that is 0.1. What is the rate of the reaction? Again, the molarity is represented by the brackets. So we're going to take our delta H concentration, which we know we went from 0 to plus or to 0.1, so that'll equal 0.1. Equals are all over, don't put the equals over 30 seconds. So we know this is our concentration over 30 seconds. This will give us, sorry, you can't really see, 0.0033 moles per liter, I will put it back, moles per liter second. So this will be our final answer. Sorry, I'm trying to hold the camera and show you guys the example at the same time. So, or you could simply put moles per liter, again, capital M molarity. So that is this example. Some factors that affect the reaction rate are going to be temperature. So if you increase temperature, you could most likely increase it. This happens almost always. You could also agitate it, like stir it, mix it in some way. This is going to be agitation. Or increase the surface area. So instead of putting it in a long, thin beaker of some kind, maybe putting it down on a more flatter surface, like a big bowl. Also, the concentration of reactions is very important. So the higher the molarity of the reaction, the faster it's going to move forward. Also, the addition of a catalyst. A catalyst is very important, and we're going to talk more about a catalyst later. The catalyst speeds up reactions. Make sure you're doing your quizzes.